Hi, Mr. Crane here. We're on day 3 of our solar system scale, and we're just going to pick up right where we left off. So yesterday, I pulled this up, and I had drawn an eye up here, and I said that on the scale that we're looking at currently, that we computed all the calculations for the size of our planet in relation to how far the distances are between each planet from the sun. If we say that the smallest thing that a person can see is zero point 0.1 millimeters, then when I look over at my, excuse me, when I look over at our assignment and I'm looking at all of these, then there's certain planets that I can see and certain planets that I cannot. So if zero point 0.1 is what I can see with the naked eye without magnification, then 30 is obviously bigger than 0.1. 0.1 would be like this right here. So I'd be able to see Sun, I'd be able to see Mercury, I'd be able to see Venus because it's 0.2, Earth is 0.2. What about the Moon? In the tenth place right here, it's not a 1, it's a 0. So that's smaller than 0.1, so I wouldn't be able to see that. I'd be able to see the Mars, I'd be able to see Jupiter, Saturn, Uranus, Neptune, Pluto. Pluto, again, smaller than zero point 0.1, so I would not be able to see it. Alpha Centauri, if you're talking about it. So let's go to the third scale then. That was our second scale that we worked on. Our third scale today, forget about the questions for right now. The third scale is going, because we can only see most of those planets are really, really tiny on our football field. We need to come up with a scale that's quite a bit larger, a different scale, and that's our disadvantage here is we're having to use more than one scale to represent our planet's distance versus planet's diameter. So I've chosen to use a globe. Everybody's seen a globe before. This globe, I've chosen to use a globe as our representation of the Earth. Since this is a model and that globe is a model, it's not the real Earth, so it's a model of the Earth. All right. So if you notice right here, Earth is 12,800 kilometers in diameter, and I'm representing it to be 30 centimeters. Okay. So I've written right here the globe to be 30 centimeters. So let's figure up or show you how to come up with the scale diameter of sun or planet in centimeters compared to our actual diameter. All right, so I'm going to use the Earth as the example. So I said Earth is 12,800 centimeters or kilometers, sorry, and we're using 30 to represent it. So let's go and try to figure this up. All right, so I'm going to pick my pen, pick my blue color here. Let me move this if I can. Pick my blue color. All right. I like the blue. Sorry, it's my favorite color. Okay, so I said 12,800 is in kilometers. Make sure we're right. I don't want to say we're 12,800. That's correct. All right, 12,800 kilometers is the diameter of Earth. That's a comma, not a point. All right, and we're going to say that 30 centimeters, the size of that globe, is our relationship. So before, remember, we did 100 to 4,500,000,000. So this one we're going to do 30. 30 centimeters is to 12,800. All right, so here's our new, we have to set up a new equation. What yesterday we've been doing the distances, so that's the distances from the sun to Neptune. Now we're doing, I'm going to put it right here. Now we have our Earth, and we have 12,800 meters across, kilometers across here, but I want to represent it with our globe. to put out on the football field. So I'm going to say 30 is to 12,800 as X is to the actual that we're looking for. I was going to draw a box, sorry. Actual that we're looking for, okay? So I'm going to re-represent that since we've been using it as a box every time. So, so 30 is to 12,800 kilometers as X is to our actual. Because we're setting these two equations to be equal, we can cross multiply them. This is proportions, all right? So if I cross multiply this, then I get 30 times actual. This is your actual diameter, all right? 30 times your actual diameter equals 12,800 times X. 12,800 times X, okay? Now, I need X by itself because I want to find out what my number I'm looking for. I want that column for scale diameters on our football field. So I'm going to, right now they're multiplying times each other, 12,800 times X. So I'm going to divide by 12,800. Bear with me, I apologize. I'm not the best at writing this on my computer. So that is basically 12. Anything divided by itself is 1. So I haven't changed my equation at all. So 12,800, those can cancel out. And what I do to one side, so now I have X on itself, on by itself, because I canceled it out. So now I have 30 times my actual, I'm going to represent that as a box now, is and divided by 12,800. Okay. Okay. So when I get that, so right here, I would have, we're talking about the Earth right now. So if I put 12,800 right there, if I did 30 times 12,800, because that's my actual distance of the Earth, I'll show you this, and I divide it by 12,800, then these are going to cancel each other, and what I'm left with is 30. So X is equal to 30. Okay, so that makes sense because let's drop this real quick. Looking at our graph, I said here's the actual. I'm representing it as 30, so 30 is my scale diameter in centimeters. I could put any of these numbers in here. I'm sorry, any of these numbers in here. So what I'm saying, these numbers right here, this column. Sorry, I don't know why I did that. So this column, oh my goodness. Holy moly. So anyway, I'm representing that column. The actual diameters is what we're looking for. So you're looking at me now right here. All right, so we're looking at, where am I at? Right there. So we're looking at actual diameters now. So let me find them again. I guess I scrolled up by accident. All right, right there. So nope, one more. So it's the last part of the project, except for answering questions. So if I let's look at Mercury. We'll use Mercury real quick, just to give you an idea of what we're talking about. So I'm gonna go down here one more time. So we're gonna use Mercury. I forgot what Mercury was already. Mercury was 4,880. All right. So I'm using this right here, 30 times my 4,880. I think that's what the number was. Let's double check that. About 12,800. And that's going to be equal to, once I do that, so I'll get my calculator out. So I don't trust the math on that page. That was the students, and I haven't checked it yet, see if it's right. So look at my calculator. So I go 30 times 4,880 divided by 12,800, and I get 11.4375. You can go out to 3 decimal places if you want. 375. 4 is fine, and that is in centimeters. Okay, so that's mercury. And we'll look at this, and they were right. They got it right. All right, so that's how you do it. It's no problem doing that. This final column right here, what you're trying to do is, it's easy. You take a tape measure and we'll go to look at 11 centimeters. I'll get a tape measure real quick. So on a tape measure, if you look at a tape measure, the bottom of it, let's see, on a tape measure, the bottom of it, on the top is inches, and the bottom of it right there, between each one of those little 2s and 3s at the bottom are millimeters. Are very tiny, very tiny. I don't even know if the camera will see that. So they're tiny. Each one of those is a millimeter. So there's 10 millimeters in a centimeter. So these can also be centimeters. So whenever it says 11.43 centimeters, 11.43 is about right there. So what is a ball that's about right there? It's about a softball, really. It's a softball, all right? And then 28 is about right there. Now they said a girl's basketball, so that is about a girl's basketball, all right? In fact, I think girls' basketballs are about 24. The globe, we've already said. 8 is, that's 8 right there. So it's about like this. So it's a ball about that shape. It's about a tennis ball. Then there's trampolines. Those are huge. Tractor tires, kiddie pools, and baby trampoline, and then tiny golf ball. So that should help you out. Hope that worked. Good job. Adios. And then tomorrow we'll do the